today we're going to start the Cisco IOS, start looking at it. And this is Cisco's iOS and SDM. SDM is Security Device Manager is what it stands for. It is a GUI that can be used to manage the Cisco IOS. However, it's a good thing to learn how to use in practicality. The CCNA exam, the consolidated CCNA exam, unless they've changed it recently, is all command line. So that's where our labs will go. Packet Tracer does not support SDM. I will make some more virtual machines today so that you guys can have your own virtual machine. At the end, he has an activity to install the SDM, and then he recommends that you download and use, configure the SDM demo. They both, I put them this morning in your materials for the course in the labs link. They're in there, as well as on the virtual machines. They're on the default gateway. So you should be able to log into the default gateway and the username for the default gateway. And the reason I say default gateway, there are like 3 virtual networks out there. The .1 address will be the default gateway, whatever it is. The username is class, and the password is capital P password 1 to log on. You should see a share. One of them says routers. That's for here. It's got the SDM that'll work with this demo. The newer SDMs don't really open it. They just say no. And when you use the demo, the address, the router that you're going to connect to is 127.0.0.1. So with that, that is there. He's got a little exercise at the end, and there's some more SDM stuff in the next chapter. We may look at it a little bit there. I don't really focus on it because if you're going to take the 640-802 exam, as far as I know, it's still not part of that exam. It is part of ICND 1 and 2. I have read. I haven't taken it in 2 parts. If you take the CCNA security, its focus is configuration with the SDM, not through the command line, because they do things in there that you're going to have somewhere around, I don't know, 100, 150 lines of configuration that this will do for you in firewall types of configurations. The Chapter 4 objectives, the Cisco Router IOS, Internet Operating System. And all of these new devices, the little tablets, are not disk operating systems, true? Because they don't have disks. They are Internet operating systems, and that's what the routers use. They're not really disks. There is flash memory available in them, and they use an Internet operating system. Talk about a little bit about enhanced editing. The whole objective of this chapter is to get introduced to and get logged on to the router to do some basic configurations. There's really not, honestly, that many different commands that we need to know. You need how to get into it, know how to do in global configuration mode, get into the interfaces, passwords, those sorts of things. And descriptions. Descriptions is a really big deal that most of us don't do a real good job with, where you put a description on the interface that tells you what you intended for it to do. You'd probably know, unless you have thousands of them, but whoever's coming in behind you may not know what that particular interface does. So those kinds of things. And those are the administrative functions, the host names, the banners, the passwords, and interface descriptions. There are labs to configure all those. These labs, the ones that you have, and yes, there are a lot of them, significant number of them, they're not really in-depth labs. As we go into the routing protocols, we'll have a little bit more extensive labs, but fewer of them. But to learn the different commands, the whole thing is to do the different commands. So that's why there are a lot of different labs. One of them goes through the setup, which will start up if you don't have a configuration. Another one I take you through, have you go through the activities that he's got at the end of the chapter, which goes through a number of different commands. Again, the more times you do it, I think probably the better it's going to be. And then verifying your configuration, the objectives here. The Cisco Router IOS carries the network protocols and functions. What are we going to do with this thing? And we'll go back to, what do routers do? Why do we need routers? It's just a lot of trouble. They're a real pain. Why do we need them?
Routes information.
Routes information, what does that mean? I agree, but what does that mean? Routes information, you're using the word to define the function.
You can bridge your private networks with public networks.
Bridges, private networks, public networks, that's one of the things that it does. That'll come later on in net.
Right.
What does it do? It finds networks, doesn't it? It is able to, I don't want to use the word route because I've already said that, and that is kind of using the word. It's able to find the path to send information from one location to another. Very much like if you go to Google Maps and you look for a route, a path from here to someplace else. It'll give you the directions, and that's what routers have. And they have different directions to go to different networks, different places, using different protocols. And when we get into the next couple of weeks, we're going to look at routing protocols. There are others, but the ones for CCNA are statics, RIP, 2 versions, EIGRP, and OSPF. Next week we'll do statics and the 2 RIPs, and then a week after that we'll do EIGRP and OSPF. They're a little bit more, the complexity increases a little bit as we go through the protocols themselves. Connects high-speed traffic between devices. And high speed is a matter of perception, I guess, now. We can use in these things serial connections, which are not necessarily going to be really high speed. We can use Ethernet connections. We can use fiber connections. Lots of different things, because the fiber could be either Ethernet or serial. So a number of different things that we can do. If you keep going into the routers in the CCNP, you can bundle the connections together so that you actually increase higher speeds. We can put 2 Ethernet connections together, 2 gigabit Ethernet connections together, I think up to 4 gigabit Ethernet connections together, so you can get up to a 4 gigabyte channel amongst those things. So you can do that. Add security to control access. One of the things that you're going to do in these labs is set passwords. What you're also going to find out is that a couple of passwords, some of them are relatively secure, some of them just are not so very secure. If you can see the configuration file, we'll look at that in just a minute in an example. You can encrypt passwords in Cisco, but by default the encryption is turned off because it's a very weak encryption. If you want to crack the Cisco service encryption, you can just go to the internet and search for crack Cisco password or something like that. There's a couple of online password crackers that will do it. If you can get the hash, it'll crack the password for you in maybe 4 or 5 seconds. So it's not a highly secure, their encryption is not highly secure. One of the things that you depend upon is the ability to restrict who can actually get there, who can physically get to a router. What we're going to find out, and you have a password recovery lab to do, is that physical access is a really big deal with these things. If I can get physically to a router, I can get into it. I can do just about anything that I want to it. Not all that difficult. Provides scalability for growth. Allows us to put the subnets in. And we've kind of done that in the building here. We have a number of different subnets, and as we add a room, as we put in another classroom, we can add a subnet relatively easily. And because of the way that the routes are summarized, supernetted, whatever you want to call it at Virginia Beach, they don't have to get involved because all of their traffic that begins with 10.60 is sent to Roanoke. Now when it gets to Roanoke, Roanoke can then break that 10.60 traffic up into the 64 network, the 211 network, the 208 network, the 201 network, and whatever else is available. There are a number. I think there's probably about 6 networks in the building. So we can break those things up. And we can scale it because all we have to do is create more networks, put another route table into the local router, and the distant areas don't have to do anything except send the traffic here. Supplies reliability, the routers themselves. Cisco is a very reliable product. They also have pretty good warranty that you can get. It's not something that is a default. You have to buy the service contracts. And oh, by the way, unlike Microsoft and all those guys that give you automatic updates, you know, they don't do that. If you don't have a service contract, you have a hard time getting the iOS updates. So it's kind of what you buy is what you get. If you have the contract, if you have a password with them, because all their stuff is password protected, then you can download it. Otherwise, it just says thank you for visiting or something like that. They have some stuff that they give away, but generally the iOSs are not one of those things. They do a good job of living up to their warranty. We had a router that went down one afternoon years ago. We haven't had any Cisco failures in a long time. Called up Cisco. 9 o'clock the next morning, there was a new router out there on the front porch. And since we have the ability, and it's the TFTP lab, the ability to save our configuration files, all of the configurations that you do, off of the router, had a copy of it. All you do is put that one in, upload the configuration files, turn it on, put an IP address on it so you can communicate with it. Upload the configuration files, restart the router, and you're done. You don't have to go back and type your hundreds of lines of configuration in. Upload and download. When we talk about the protocols, TFTP to UDP. So why the heck we want a TFTP server? It's not very useful. It is very useful for downloading these particular things. That is the thing that you use. TFTP is a server. It's a piece of software that you can install on a Windows machine, on an XP machine, on a Windows 7 machine, which we're doing here. And that's one of the reasons I want you to do the physical lab, so that when you're actually doing these, you know, yep, I need to save all my configurations. You also need to save all your iOSs, because if one of them becomes corrupted, there is a process that you can go through to put the new one in there. You can also upgrade them. One of the kind of dangerous, kind of fun things to do with that is when you upgrade an iOS, the first thing it does is erase the existing one. If it doesn't fit, we got a problem, because if it doesn't fit, you now don't have an operating system in Flash. And if you didn't make a copy of it, you can't put the old one back in. So make a copy of it so that if it doesn't fit, says, oh, we erased it, but the new one won't fit, put the old one back in. As long as the router's running, it's okay. Everything runs in RAM. I'm going to have a graphic here in a minute that's got the different RAMs, the different place that things are stored. So it does supply reliability. There are protocols out there that allow you to have multiple routers, so that if one goes down, the other one automatically takes over sending the information, writing the information. This is one of the labs. This is a picture of the backs of some of Cisco's products, different products up here. We got a 2610, a 2811, and an 1841. If you look at these things are in different locations, different numbers of them. The ones that you're going to look at are 2600 family. I think so. Some of 2610, some, I think one of them at least is a 2612, but they're a 2600 family, which is going to look something like this. These are modular routers. These little things with dots around them are modules where you can take the cover off, insert a module, insert, install functionality. So that if we had one of these, and you notice that it doesn't have any serial ports that I see here. It's got an Ethernet port here, fast Ethernet port, lots of different blanks. The ones that you're going to see over here do have serial ports on them. These have, and these things right here are are called smart serials or serial ports. They've got 1, 2, 3, 4, 5, 6 serial connections. Serial connections, the ones that we use to go great distances. Ethernet's still going to be an issue. A lot of these are fast Ethernet, and this one's got some fiber over here. Each of them is going to have a console port, RJ45 console port. This one actually has 2 Ethernet ports, console port and an aux port. Console port is the one that we plug a rollover cable into, a rolled cable, rollover cable into, connect to the serial port on the computer in order to communicate with the device. Most of Cisco's devices come with no configuration. ISRs, and he talks in the book about ISR routers, integrated service routers, have a basic configuration in it that allows you to connect via a web page in order to do the configurations. But the big routers, these things here are not integrated service routers. You're going to connect into the console port, start it up, and it's going to ask you if you want to go through the setup. After you've done the setup, there's a lab to do the setup. After you've done that, should be the last time you ever use the setup mode, just so you know what it is. Say no, because you're only going to configure the things that you want to configure. You're going to know the commands to go do that, which is a lot quicker than trying to go through that setup mode. So this is part of one of the labs. What goes into these things? The Ethernet port obviously is an RJ45. If we go to router, it's going to be a, what kind of cable? Router to router. Crossover, like to like. And please note when you do these things, this Ethernet 10 base T port RJ45. This is a NIC. So if we plugged a computer into here, a NIC from the computer to the router, it's going to be a crossover cable, NIC to NIC, like to like. If we plug this thing into a switch, it's going to be a straight through cable. Console port is a roll cable. The aux port is essentially a console port. And now this is the important part, but it's really designed for a modem, for out-of-band management. That is, let's say that you're here in Roanoke and you're managing a router in Los Angeles, and you screw up and lock yourself out. Ouch. How are you going to manage it? That's what the aux port's for. If you had a telephone connection, it wouldn't matter. You dial to the modem, modem's connected to the aux port, you have a second means of communication with it. So that's what the auxiliary port is designed for. I think what you'll find is if you plug the rollover cable in there, it'll work just fine also, because it's an RS-232 port, just like the console port. Roll port, rollover cable, connect to the serial port. One of the things that you will note on these machines, as well as on most of the new laptops, is they don't have any serial ports. You have to get a USB to serial converter. These things are still serial. A lot of the routers come with USB ports on them. That's not for communication. That's for memory. That's for memory modules go into those things. So you can't plug those in. They still go through the console port. And if they don't have any configuration, no IP addresses on them, you've got to start somewhere. You've got to start with physical connectivity as we go into these things. They do have power switches, and Packet Tracer allows you to turn the power off, turn the power on. Packet Tracer allows you to put modules in here, and I think I've got at least one of the labs, and I'll demonstrate how to do those in just a minute, how to put modules into a router in Packet Tracer. A couple of other things that will simplify your life, and if you take the certification test, you get the same ability. Cisco gives you the help files in the cert test. Cisco has command completion, and I notice that students really are hesitant to do that. Use the tab key. There's a whole lot fewer, and I'll demonstrate that, and we'll talk about it here in a minute. A whole lot fewer mistakes if you do the tab key, and it finishes the command for you. And if it doesn't finish the command for you, it means you started it wrong. Either that or it's not unique. The routing process, and in one of those little SCORMs, the little funny ones down at the bottom, is the routing process. I've seen this in a couple of places, or the boot process. Router is just it's a computer. It does the same thing. It goes through post, power on self-test, just like an IBM PC does, just like a Macintosh does. Looks for the Cisco IOS from flash memory. The iOS loads and looks for a valid configuration, the startup configuration file, which is stored in non-volatile RAM, NVRAM. Again, I'm going to have a picture of the different RAMs here in a minute. There's a bunch of different places things can go. One of the things that it forgot to say up here is it looks at the configuration register. The configuration register is that dreaded hexadecimal number that tells it where to look for these things. When you do the password recovery lab and when you recover a password for real, what you do is basically lie to the system. You put in your own configuration register. And you tell it to load the iOS, but don't load the configuration file because that's where the password's stored. If we don't load the configuration file, no password. Once we get in, we can then recreate the password. What we do is load the file that we want to use, change the password, restart the router, and we have the new password. So the manipulation of this thing is effective. Sorry?
You have to overwrite the old password.
You have to overwrite the old password. Sure. But once we're in, that's easy to do. Because it doesn't do like Windows. In Windows, if you get into it, if James left his computer open and I did a Control-Alt-Delete reset password, it may do something really tricky like ask me what the old password is. They don't do that. Because they're presuming that physical access has been controlled. Physical access is a really big deal in these devices. If you can get physical access, you can do lots of stuff there. I had a guy years ago said, oh, that doesn't sound so easy. I said, well, so hard, and it's not, as long as you've got the router sitting right there in front of you. Okay, now then, let's put the router in the NOC. Now do that stuff. Oh, wait a minute. I can't turn the power off. I can't connect to the console port. Yeah. Physical access, really big deal with these devices. So when you're doing these, remember that. So it looks for the Cisco IOS from flash memory, one of the memories, flash memory, the configuration in NVRAM, non-volatile RAM, which non-volatile you can kind of think as a form of flash. These routers are going to have some memory that's built onto the motherboard and some memory that is in a module. If it's a valid configuration file is not found in NVRAM, it goes into setup mode, which many of them will when you start the devices, start the exercises. If you do that, you don't want to go through setup mode. It says, do you want to go through setup mode? Just say no. It said one time for the setup lab, go through setup mode. After that, should probably say no every time and just go in and configure the things that you're there to configure. Basic management setup step by step, and again, you've got a lab to do that with, and it's pretty self-explanatory as you go through it. Put an IP address on this interface, put an IP address on that interface, name the router, put some passwords in. We're going to talk about the passwords here in just a second. Put a couple passwords on it. Do you want to allow telnet sessions, those kinds of things. Instead of going to the individual element sections of it, you do it all at once. Extended setup, basic management, there's two types. It says, do you want to go into basic setup, extended setup, and I think I have you go no here, so you go through the extended setup. The extended setup actually asks you about 2 more questions than the basic setup as you go through these things. Command line interface, that's what we're going to be using mostly. Packet Tracer has this really cool config tab, which I think I have locked on all the labs. Because it doesn't do you any good to know how to use that really cool config tab, because when you plug into the console port of a router, there is no really cool config tab. All there is a command line. In some cases, I have locked the CLI, command line interface, on the routers, which means you're going to have to connect a computer to it and go into the console port just so that you see those things. If you do the testing, if you do it for real, you're going to have to go through that process. B, if you do the testing, they're going to take you through our computer's console port every time you do a configuration on a router, and they do have labs. They'll have at least 3 labs where you do configurations, and probably at least 1, maybe up to 3 or 4 questions where you have to connect to a router or a switch in order to answer the questions that they ask. So that's a process that you need to know how to do. The command line interface, the thing that we're going to use with this thing. Command line interface, more flexible than setup because you don't have to go answer the questions that they ask. You go to the areas that you want to configure and configure what you're there to do. Once you're done, save it and move on. One of the things to remember in Cisco routers is when you make changes, you're making changes in RAM, volatile memory. If the router gets turned off, bye-bye changes. You have to save those changes, and there's a lab to do the copy. It's really tough. Copy, run, start. Copy the running configuration that's in RAM to the startup configuration that's in NVRAM, so that if the router goes down, then when you restart it, it loads it, like in the boot process, from NVRAM. Back to that LA thing, if we made a mistake, one of the things that you can do, and I'm sure that it's not in this chapter, but it'll come along, but if it doesn't, there is a command that you can put in that's a reload command that tells it to reload the router every so often, so that if you screw up and you put an IP address on the system and lock yourself out while you're telnetted into it and you mess up, and I've done this, put it on the wrong interface, and about the time you say save or OK, or you hit the enter key, you say, no, that's not it. If you have the reload every 10 minutes, 5 minutes, 15 minutes, then you wait 10 minutes, 5 minutes, 15 minutes, whatever, and it'll restart the router, because since you didn't save that configuration, it's not in non-volatile RAM, and when the router restarts, it has the old config file. So there are ways around helping you with those mistakes. To use the command line, just say no, and again, I'll demonstrate that one here in just a minute. User mode, we're going to talk about two different modes here. User mode, and the visuals will tell you which mode you're in. Router, the greater than, you're in user mode. Most of the view statistics has a very limited number of commands that you can use. You can't make any changes here. You can only see some things about the router. The mode that you want to get into, and the one that can be, will be password protected, privilege mode. And the indication here is router with a pound sign, used to view and change the router configuration. It actually allows you to get into the configuration mode. So and this is sometimes called the enable mode, and that's what you'll hear me call enable mode. Enable mode, privilege mode, pound sign. The reason they call it enable mode, to get from here to here, you type the command enable, or EN. One of the things that you're going to find out as you go through these things, if you type a string of characters that becomes unique, EN for enable, that means that no other commands start with EN, Cisco will auto-complete them for you. You can use the tab key to see what they are, or you can just hit enter, and if it is unique, it'll just execute the command. If it's not unique, it'll tell you that it's an ambiguous command, which means it could be more than one thing. Ambiguous means that we gave a string that is in more than one command. Some of the things that you will see here. Global changes, configure terminal or config T. This should be, it says config terminal, it should say configure terminal. Config becomes unique. T means that there's only one command after config that starts with T, so it will do the auto completion on each of those commands. We can type configure terminal, config terminal, or config T. If you just type config, it'll ask you what you want to do, and the default is terminal. There are other options that we can go through. Changes made to running config in DRAM, dynamic RAM. As we make changes, it's in volatile RAM, dynamic RAM. Until we save those changes, if the router gets turned off, power failure, or whatever else, and it restarts, it doesn't get reloaded. We had that happen to us years ago on a switch. One of the old switches. Typically on a switch, you say once you make the changes, it's made on the switch. Not always the case. Sometimes you need to copy the running config to the startup config. Always do that just to be safe. We made these changes, said, oh, it's a switch, changes automatically made, stored in non-volatile RAM. Power failure came back, and it restored all of the old configs, which were security configurations, which were 802.1x, which meant that we couldn't get onto it because we couldn't get the ports turned on. So you had to go back and figure out what you did or whoever did whatever when, documentation, saving these things in order to do that. To change the startup config and NVRAM config memory or config mem to change these things. Any configuration changes need to be placed into RAM. Typing config mem or config net from TFTP host will append to the current running config. Doesn't overwrite the running config. So if we copy something from a TFTP into the running configuration file, it merges the two, which means that if we have things there that we don't want there are still going to be there. If we copy from the running config to the startup config, it overwrites everything that's in the startup configuration file. So some of these things are going to merge, put the two together. Some are going to override, and you need to be careful of those if you're taking something from like a TFTP server back into your router. The running configs are going to be merged. The startup configs are going to be replaced. Configurations, the command line interface prompts and interfaces, sub-interfaces, line commands, routing protocols, these are all things that we will do as we go through the labs. And probably some of those are just as easy to demonstrate. What this is showing, really small router, the pound sign says that we're in enable mode, that we can configure this thing. The question mark is the indication that I want some help. If you just do a question mark, it tells you all the commands that are available at that mode, at that area. A couple of places you can use this. If we type AC here, ACC and a question mark without a space, it's going to tell us everything that starts with ACC. So it should give us this first three commands. Again, we'll demonstrate this here in just a second. If you type part of a command space question mark, it'll tell you all the things that are available for that. One of the ways when you forget all this stuff, and yes, you can use it on their tests also because they have the help function there, is you type the part of the command that you know, space question mark, tell you what's going to be there. Then you put that in, space question mark, what's going to be there. And you can work your way down commands that way. If you're really configuring them, that's a method to do that. This is the router, the C, question mark, clear clock, configure, connect, copy. So these are all of the commands that start with C. Would be continued C and then whatever would continue with those things. Enhanced edited commands, router command history, and you'll look at those things in the labs. Gathering routing information, show version. This is a big deal. Show version tells you the version you're in. It also tells you at the very end where the configuration register was. So that in the password recovery, when you change the configuration registry to not load your config file, 2142 is what you can 0x2142 is what you're going to change the register to do that. Once you get that changed, you need to know what to change it back to. That's one of the things that the show version is going to do for you, the version of the software that's in here. Some editing commands, enhanced editing commands. These are kind of handy, I think, and the author says, oh, this is not a really big deal, but when you get into the console, the tabs and those kinds of things don't work. The only thing that works, the delete key works, the backspace key works, and the arrow keys work. If you move your mouse around and click it someplace, that doesn't move the cursor. So if you've got a really long command and you want to go back to the beginning of the line, Control A would get there, Control E moves it to the end of the line, Escape B moves it back one word, Control B back one character. These are things to just kind of practice with. They are handy when you're in the console function. I think they're handy in the console function. So more of those. Whole bunch of these things. The other ones that really are handy, unless you just love to type, are Control P, Control N, the up arrow and the down arrow key, which will give you, just like in DOS key, just like in Linux, the previous commands. So the up arrow key, previous commands, down arrow key go forward with the commands. Control P and Control N do the same thing. Show history shows the last 10 commands, and that's the default. You can change how many commands that you want in history by changing the number, by changing the history cache. Show terminal, the terminal configurations. Terminal, there we go. Terminal history size. I knew we'd get there. Terminal history size. How many commands do you want stored in this? And I think it goes up to, it does go up maximum 256. That's an awful lot of commands. But it will keep those for you. This is the one, and I copied this out of a, as you can see, out of a lecture. We have RAM, the different areas that places things can be stored. RAM, running config, so the routing tables, the ARP cache, packet buffers all go in RAM. RAM is the volatile memory. Show running config is the command that they show here. Show processes, CPU, show protocols, show IP route, show mem, the things that you're going to, IP route would be part of the routing tables that would be in physical RAM. If we haven't saved this information to non-volatile RAM, where this startup configuration file is, we made 100 lines of changes here and we didn't save it, and somebody trips over the cord and turns our router off, or we have a power failure, we just lost 100 lines of configuration. Save these things when they're working, save these things to NVRAM. The other advantage that you can leverage if you make a mistake and everything gets really fouled up and you haven't saved it, just restart the router. And you'll get the old configuration that's in NVRAM. The flash memory has the IOS, and there's a show flash command that you can use in this thing. ROM is a basic startup, just like the ROM in a computer. If you get a command prompt that says ROMmon, that's where you are. That's not really something that you want to see. What that means is it couldn't find the IOS. So it went into ROM mode. There are processes, and if you do that, they're a little bit different for each router. There are processes that you can find step-by-step instructions on. Boy, I've got a problem here. I've got a copy, but I've got a copy of the iOS. Just go get the how to restore the iOS from ROM mode from Cisco. They have probably more information available than any human could read in their entire lifetime, I think. Because they have infinitely detailed files, documentation on every device that they make and all of their protocols. An awful lot of information at Cisco. And it's all available free, normally in PDF files. You can just download them and save them, something that you want. The 2600, I think I put in this morning, the 2600 password recovery, which has got some other things, and it's a step-by-step process on how to do that, which you can use for the password recovery lab. It's also in the book. It's also something that should take just a few minutes once you've practiced it a couple of times. Show version. And take a look at this. The system image file flash will tell you which one you have on your router, so that if you need to update it, upgrade it, you know what's there. Memory shows up here. Processor with 276, 486, 512. The way you find the total amount of memory is you add these two together. This is how much on the module, how much on the motherboard. So to get the total memory, you have to add the two. And on down, one of the things I said, the last thing in here is the configuration register 2102. What that's telling this system is to look for the iOS and flash and look for the startup configuration file in NVRAM. If we put the 2142 in here, it tells the system to look for the iOS and flash. And don't worry about the startup config because it's not there. Don't look for the startup config. That's how we're going to get into the system in order to reset the password. Administrative functions you can configure on the router and the switch are host names. Name these things. And this is a really tough one. Host name, and then whatever you want the name to be. You can't have spaces. If you want a space, use the underscore. If you use a space, it'll say, invalid command. Banners, which are basically, they go away, don't use this thing. Banners should be just like we have the warning on the computers before you log on. You should have some sort of a warning here that doesn't say welcome. That don't have welcome goes back to there have been court cases where you say welcome and people hack the system and said, you said it was welcome. Didn't say what it couldn't do. You need to say there's official whatever, some sort of official wording on these banners so that if somebody does that, you have some basis for prosecution. Passwords, and there are a bunch of passwords when we go through this thing, and you're going to configure a number of the passwords we're going to have. And I'll steal the thunder of the hopefully steal the thunder of the PowerPoint. When we get into this thing in enable mode, we're going to have an enable password and an enable secret. The enable password is not encrypted. The enable secret is hashed, uses an MD5 hash, so it's relatively secure. We're going to have a telnet password, we're going to have a console password, so a number of different passwords that we can put on these things. And we can use RISC servers, TACAC servers, or we can store them locally. You can have single passwords or you can put usernames in here. So there are a lot of different ways, and that's one of the things, and that's more a focus of the CCNA security one, how to actually control who can do what. You can actually get this thing that you can put usernames in here with passwords and restrict a particular user to which commands they can use. So it does have lots of flexibility if you go further into it, beyond the scope of the CCNA, but just so that you know that you can do those things. Interface descriptions are kind of handy to have so that not necessarily for you if you remember what they all are, but whoever comes after you, oh, that's what that one does. That's the WAN link to Miami or to Los Angeles or to San Diego or whatever else, so you know where it's supposed to go out, what it's supposed to be doing. Host names, router, the pound sign says that we've gone to enable mode. The config says that we've gone into config T, configuration of terminal config mode. Config mode is where we actually make most of the changes. If you start typing a command at the enable mode and it tells you that it's an invalid command, always check your mode. I'm famous for doing that. I do that on the tests, and it gives you the correct response. Then you say, oh yeah, I'm in the wrong mode. Go to the configuration mode. Try and put an IP address on an interface, you've got to be in interface mode. If you're trying to configure a password on a telnet, you've got to be in the line VTY04. You've got to be in those areas. So be sure you're in the mode that you want to be in. It says host name Todd, and immediately change the host name to Todd. Descriptions, interface, Ethernet 01. You notice when we interface, we go to config IF, configure interface. Description is the command. Description says sales LAN for this particular interface, interface Ethernet 0. You're going to find on most of these labs that the interfaces are going to be fast Ethernets, not Ethernets. And I think that you'll find on the 2600s that they're fast Ethernets. If you look at the 2500s back there, they're Ethernets. Difference between 100 megabits per second, 10 megabits per second. Banners, types, execution, incoming, login, message of the day. The banners give a message at four different functions on the routers themselves, so that you get, when you try to log in, so official business only, if you're not this, go away or something, I don't know. Whatever you want to put in these things. Message of the day, different types of managers. The delimiting character, when you type banner MOTD space, then you have a delimiting character. It can be anything. it's kind of handy to use something like the pound sign or the dollar sign, something that wouldn't be part of your message. If you just type banner MOTD space, this is my router, then M becomes the delimiting character, and then M becomes the other delimiting character, and that's the message in between. There's a lab to do that. Again, recommend that you use something like the pound sign or the dollar sign, something that's not going to be a character in your message when you use the delimiting character. Delimiting characters are like the quotes that you put around what you want the message to be. Passwords. First two are used for the enable passwords, to secure the privilege mode, the router, and then we go to enable. Console port, auxiliary port, telnet can all have, and as well as the two enable passwords, can have passwords on all these things. So we have 5 passwords that we can use. The enable password, and we'll look at that here in a few minutes, is not encrypted. The enable secret is. These are not going to be encrypted. A couple of things. Telnet password, you have to give the authority to log in. If you put passwords on it and you don't give it the login command and you try to telnet, it gives you this really cool message that says that password's set, but you can't log in because you haven't given the authority to do that. Or if the password's not set, you can't do that unless you give it the no login. No login doesn't mean that you can't log in. It means that you don't require a login password. Enable passwords, enable password Cisco, enable secret Cisco, and you shouldn't be able to, you're not supposed to be able to use the same ones. Auxiliary password, console password. The console password is one that you would use, and you would have kind of a double protection here. One, physical access. Then if they got physical access, you have a password. Again, it's something that's not that is overcomable because you have physical access to the machine. If you got physical access to the machine, you can get past any of these passwords. Console not as easy as the enable password. Telnet passwords, auxiliary passwords. So, and you got some activities to do this. The default, it says service password encryption. The default on the Cisco routers is no service password encryption, which means that these unencrypted passwords up here are plain text. If you want the passwords to be encrypted, you need to give the command service password encryption, which will take away the no. What you're going to find in Cisco is typically whatever the command is to undo it or to turn it off, you just put no in front of it. Really good for the up arrow key. You did something, I want to undo it, use the up arrow key, Control A to go to the beginning of the line, type no in front of it, no space, hit enter, and it should undo that command. So typically to undo a command, put no in front of that command. What you can do with these, enable the service password encryption while you're putting the passwords on. Because you don't change passwords normally every day. So service password encryption, use your enable password, your aux, your console, and your telnet, put those on, and then turn off the password encryption with the no service password encryption. It doesn't decrypt them, it just doesn't encrypt anything else until you turn it back on. It just means that there's another, that if you leave it on, it's just another service that's just taking up small parts, but it's taking up part of the CPU. If you have enough little consumptions on these things, then you wind up with quite a bit of CPU utilization. Password descriptions and host names, we kind of talked about that, locally significant. A description command is helpful because you can keep track of circuit numbers. You can also use it to make it easier for whoever succeeds you in the job as you document these things. Interface, and go through here, Atlanta config interface Ethernet 01, description, whatever it's going to be, interface serial 0. And notice that we went from config to interface. We go from the config interface to a different interface. You don't have to go back to go to a new interface. But you also note that it doesn't tell you which interface you're on. When you get down here, it just says you're on an interface. So keep track of which ones you're on as you go through these things. Otherwise, I at least wind up sometimes configuring the wrong interface. So how did I get there? But it doesn't tell you here that you're configuring interface Ethernet 0 or here that you're configuring interface serial 0. It just says you're configuring an interface. You got to know which one you're on. You can view the description with the show running config or the show interface commands will show you those things. Bringing up an interface, no shutdown and shutdown. The default configuration of interfaces on a router are administratively down. Just like I said to undo a command and put no in front of it, if you want to turn it on, you use the no shutdown command. And if you go in interface fast Ethernet 0 or fast Ethernet 0/0, IP address 192.168.3.1, 255.255.255.0, the IP address and the subnet mask, enter no shut. And you don't have to type shut down. No shut will get it done for you. Will turn the interface on. Until you turn the interface on, it's going to be shut down. Serial ports, same way. So you have to turn these things on with the no shut command. Switches are down until you plug a cable into them, the Ethernet ports on the switch. You can plug it into the router all day long. It's not going to come up automatically. A couple of things that you will see when you show those interfaces is you may have an interface up, line protocol up or down. Line protocol down means that the interface is up, it's got an IP address on it, but you have a layer 2 problem. Down means you have a layer 1 problem. Administratively down means you have a no shutdown problem. So up is good. Up down is layer 2 problem, which is usually something in the cabling itself. In serial ports could be the encapsulation protocol. Configure an IP address, just went through that. Interface Ethernet 0, config IF IP address. The IP address with the subnet mask and the no shutdown command, the no shut command to bring the interface up. Serial interface commands. In serial interfaces, we have this thing called a DTE, the data terminal equipment, and a DCE, data communications equipment. One of them, whichever one is designated the DCE, and it doesn't matter which one's the DCE, but the DCE has to have a clock rate. It says and bandwidth. You really don't have to have a bandwidth. You can have a bandwidth. But you do have to have a clock rate. If you don't put a clock rate on one of the serial interfaces, and by putting the clock rate on it, that declares it, makes it the DCE. And in Packet Tracer, when you start connecting serial ports, one of them has a little clock on it. That's the one that's the DCE. You need to put a clock rate, clock space rate. Doesn't matter what it is. I usually use 56,000. It does not affect the bandwidth. It only allows it to come up. So if you have a serial interface with an up-down, interface is up, line protocol is down, encapsulation protocol could also be the clock rate. So check to be sure, always check to be sure you have a clock rate on your DCEs. If you put a clock rate on the DTE, it doesn't matter. It just says, yeah, don't need it, won't take it into configuration. It doesn't hurt anything. So when you're doing these things, if you put a clock rate on both of them, one of them will take it, the DCE will take it, the other one won't. When you plug in physical cables, we have some physical cables back here, unlike our kind of simulators with Packet Tracer, the physical cables have a label on it that says either DTE or DCE. This one says it's a V.35 DCE, so whichever one you plug this one in would be the one that would have to have the clock rate. Physical cables are labeled as either DTE or DCE. The only time that you're going to be concerned with this is if you have two routers that you're doing a serial connection on. If you're connecting out of your system, then you're going to, the ISP is going to almost always provide you with the clock rate. Wrong button, huh? Viewing and saving, running saved in DRAM. Startup config saved in NVRAM, copy run start, show start. Erase the startup config is going to erase what's stored in NVRAM, and then if you restart it, you don't have anything changed. You need to put something in there. When you do these configurations, save them. Show run startup, ping, show CDP, neighbor detail, trace, and telnet. CDP neighbors, and there's a lab to do that. What CDP neighbors does is checks at layer 2 to see what Cisco devices are directly connected to the other device. There's a show CDP neighbors, which will tell you what devices. Show CDP neighbors detail, which will show you where the interface names are, what the addresses are, and the last lab that you have is Discover Topology or something like that. Cool little lab that you'll do with Packet Tracer to connect to a Packet Tracer that's running on Ranger that has a topology that you'll discover using CDP neighbors. And when you get through with that, you'll be really good at Telnet and CDP neighbor, because since you can only see the ones that are directly connected, you find out what those are, what the IP address is. Telnet to the next one, do the same thing. Telnet to the next one until you get to the end where until there's nothing else connected to discover the topology. Trace and Telnet, trace route in Microsoft. Telnet, we've kind of talked about. Telnet is a console connection from one end to the other. Show interface. A couple of them, show interface, question mark, show interface is going to give you an awful lot of information. If you want a nice little table about what's going on, show IP interface with a brief command at the end of it. I'll show you that one in a minute. Let me finish this up and then we'll take a break and we'll look at those things. But show IP brief, IP interface brief gives you a little table. Instead of giving you all of the information, we'll look at those different things. Show controllers interface brief. So I knew we were about done. Kind of I guess a stroll through the park here on basic commands, and that's what this chapter is about, basic commands. We'll get into some more iOS commands the next time. There's a number of labs to do associated with this chapter. There'll be a number of labs to do associated with the next chapter. The only way I know to actually figure out what these things do instead of just sitting here and listening to them and try to memorize stuff is to go do it. So that's what we want to do with the labs. Are there questions at this point? Let's take a break and then we'll look at a couple of demos here when we get back. I'd like to look at, for a couple minutes, there's some things that are Packet Tracer kind of unique, as well as look at a couple of those commands that we talked about in there. First of all, if you want to, and I put a 2811 up here, you notice that it has certain hardwares already in it. If I wanted to add something, I would first turn it off and then go over here to the list. WIC2T is the one that typically you're going to use to get a serial. If you notice down here, it's got 2 serial ports, so we just click to it, go to that area, click and drag it up into one of the areas that it fits. We now have added that hardware. This one didn't have any serial ports before I did that. Then we turn the router back on. If we go to the CLI, it goes to the startup decompressing the image. When you get asterisks, it means that it's a compressed image and that it's decompressing it as it loads it into memory. And it compresses so that they don't need as much memory. This is the, do you want to continue with the configuration dialog? This is the setup. This is where, when we get there, you don't want to do that. Just simply type no. And then press return to get started. We're in user mode. If we wanted to actually connect to these things, we'd go in here. The little blue line is the console port. Use the RS-232, connect it to the console of the router. Open the workstation, desktop, terminal. We go through the configurations, 9600, 8, none, 1, and none. When we get there, I'm now connected to the router. I'm at the terminal. The question mark, which commands are available here? If I wanted to find all the ones that were available with T, question mark with no space, telnet, terminal, and traceroute. So enable, the enable gets me into here. We talked about, and let's do the show run. Don't have anything here. Host name is router. We got the internets, the serials, and you notice that they are shut down. Duplex is auto, speed is auto, which is kind of the default, not kind of default, is the default for Ethernet ports when we do these things. No IP address. If I wanted to do configuration, config T, and then enable password, and enable secret, and it's enable secret. It's not enable password secret. If you enable password secret, then the password would be secret. If you enable secret password secret, the password would be password secret. So it's enable password or enable secret. Okay, enable secret does the enable secret, does the secret password. And broke your head, huh? And see here, I can't do that from here, and this says invalid input detected. When you have an invalid input, the caret tells you where the invalid input is. I tried to use show from the configuration mode. You can't do that. You can't do that. We can use do. That's right. This is kind of a cool command, which is new with, I think, 12.3 and above. We can use the do command, do show run, and I can do that. I'm up to my 2 passwords now. So it says enable password is password. Enable secret 5 is the hash, and then I get a string of gibberish, the hash itself. So that one is in fact a hash password. We say encrypted, it's really a hash password, not an encrypted password. The other one is not. We can use the service password encryption for those things. The continuation, if I'm going to go to an interface, I'm in config mode, IN tab interface. Fast Ethernet, FA tab, Fast Ethernet. Use the tab keys. 1, you don't make typos, and 2, it's a lot faster. 0/0. If I want to put an IP address on it, IP, ADC, the A, there are other things here. Access group or address both start with the A. So AD, tab address, 192.168.6.1. And if I just do an enter, it says it's an incomplete command because I didn't put the subnet mask on it. Incomplete command says that there's something missing. If I wanted to see what that missing was, I could type the question mark and it says ABCD IP subnet mask. And using the up arrow key, I can go back in the down arrow key, up and down arrow key, 255.255.255.0. And now the things that are available there are a whole bunch. Let me get out of here. Actually, use the do command, which it really is a handy command. You don't have to back out. You can use the do command to do something at the enable mode. So let's do show IP, and I want to do the brief, IP INT, because interface is there. IP interface brief gives me a summary of what's going on my interfaces, and these all say method, manual, status, administratively down, which means they have the shutdown command. This one has an IP address that we can see the IP address. So in order to bring that interface up, I need to give it the no shut command. It says it's changed state to up. So we do this. You notice that it says the status is up, but the protocol is down because there's nothing plugged into it. So that's a layer 2 issue. The status is up. It's got the no shut command, but the protocol is down, which means I have a layer 2 issue. That's what's called an up-down arrangement. Up is what we really want to see in these things. So let's see if we can make it up. How would be a quick way to make it up? Let's bring a switch over here. What kind of cable are we going to use? From a switch to fast Ethernet 00. Notice that we're gone into, went from red, now it's on the green. So let's go back to the console port here. And we have a message that says line protocol, up, down, line protocol, interface, fast Ethernet 00, change state to up. So we get messages on this. One of the commands that you will want to use, because as you start configuring these things, you'll get messages back, and it kind of interrupts with what you're doing. What we want to do, and these are some I don't think are in the book, you may want to write these down, is to make your life simpler. One of them is that the command is no IP domain lookup. If you type a command in wrong, what it tries to do is resolve it with DNS, and there's no DNS server anyway. No IP domain lookup, it won't do that. So we want to use a no IP domain lookup, and then we want to go into config, line con 0, console 0, and use logging synchronous. The logging synchronous, when it gets those messages, those console messages that come back, instead of putting them in the middle of what you're typing, it puts you on a new line so that you can keep putting your commands in. Those are two that will just kind of simplify your life. The show interfaces, let me get out of the exit takes you back one, in takes you all the way back. The exit took me back one line to the config. The show interface, and it says, and I'm in the wrong place again, so I still use the do command, right? Show interface gives you all sorts of information. It's going to show me all the interfaces, all of the information about the interfaces. The show IP interface brief is the one that's going to give you the little consolidated brief view, whether it's up, down, IP address, those kinds of things. To me, that one is a very useful command that they actually do in this book. A lot of books don't talk about the brief switch on this thing. So we've looked at some of the basic commands here, how you use the tab key, how you use the question mark key, and as you go through the commands, you can use the question mark to figure out what's required to complete it. If you take the CCNA, question mark works, tab works. Some people say they don't think it give you full credit. I don't really care, because it really, if they take points off, it's not very much, and to me it's just so much easier to use the tab key. For one thing, you don't make a typo. For two, if you do the tab key and nothing happens, it's either you've typed the command, started wrong, or you're in the wrong mode. Which I should have gotten when I was here in the configuration mode. Let's get through this thing, maybe. If I do an SH in the tab in config mode, it just goes to the next line. It goes to the next line because I put logging synchronous in it. Should give me a hint that there's something wrong there. If I go up one to router, SH, and tab, it finishes the command for you. So the tab can tell you that you're in the wrong level to do that particular command, or you started typing it wrong. Or there are obviously other commands that start with that. And if that's the case, SH question mark shows you all of those. If I just do an SH, it's incomplete, so I can do show question mark, what can I show? Interfaces, host, there's a whole ton of stuff that I can use the show command for. Quick and dirty, connect through the console. Some of them you can go directly to the CLI. I think that I do have on the labs that you're doing the config tab locked out. The config tab, yeah, it's a quick way to get things done, and it is a way to learn if you want to learn some of the commands, because if you do something in the config tab, you notice you have a little window down below. It'll actually type the command that you just did the action for. So if you need to back off on something, create your own little topology, drag your own router in with the config tab, do the action, go look and see what the command is. And if I did something here, let's go into this interface and let's put 192.168.7.1, 255.255, and let's turn it on. And now let's go back to the command line. It goes through the what I just did. I went to interface fast Ethernet 01, IP address 192.168.7.1 with a subnet mask 255.255. So the things that I did in the config tab actually get recorded in the command line. You can go back and see what commands are required to do those actions. Another little learning step if you need it. I think that for the labs that I've given you, though, you got pretty much do this, do that. I'm going to give you some at the end that just say, go do this, and that's what, that is more what we want as you get further into these things. Are there questions? Ready for some lab time? Going once, going twice.